Today we are going to discuss the deduction of the polar equation of a conic. You see, we already know how the Cartesian equations of different conics like parabola, hyperbola, or ellipse, how they look. And today we are going to discuss the equation of a conic in terms of polar coordinates. Okay. This is the picture you have in your book. This the book I am following, the book of Ghoshan Chakraborty. You would find this big picture, and a similar picture has been deduced over here. Just similar, but little difference is there in this picture. What is the difference? You see over here. Um, Consider this kind of conic. Say this is the conic equation of this conic. This is the conic that equation of which we are trying to compute. And on this conic, we are choosing any arbitrary point P. This would be the position of this kind of arbitrary point P. This kind of point P. And let us consider its equation as equal to its coordinates as equal to r comma theta. Now over here we have considered the same kind of curve, but the difference in between these two pictures is that if this is the focus S, in general what we do, in general this focus is this S is taken as a pole of the of this polar coordinate system. And the difference in between these two pictures is that the choice of initial axis. Over here you have observed that an arrow symbol is given over here, this kind of axis, and starting from the point A, starting from this point S towards this direction. This kind of straight line starting from S towards this direction means this is actually the position of the directrix. So S, the initial axis has been drawn from this point S towards the direction of this fixed straight line, that is the directrix. Okay, but in this picture over here, in this picture, same kind of picture is there. This is the directrix and this is the focus S, and from this focus the initial axis has been drawn just opposite to the direction of uh, the directrix. With respect to S, over here the directrix and initial axis, they are in opposite direction. But in this original picture of the book over here, with respect to this focus S, the directrix and the direction of initial axis, these two are in same direction. Okay, again I am saying that with respect to X, this is the position, this is the direction of directrix, and this is the direction of initial axis, so they are opposite. And in this picture of the book, the direction of the initial axis and the direction of the directrix from this pole or from this focus S, both of these two directions are same. So this is the difference, and depending upon the choice of initial axis, we generally define the angle theta. Generally you are habituated to define theta in this fashion. Theta is defined in anti-clockwise direction. And that is the general idea of taking this vectorial angle theta. Anti-clockwise direction of the vectorial angle should be measured from this initial axis. And over here, as because the initial axis is taken on the left hand side, therefore the vectorial angle should be measured in clockwise direction. So in this picture, the clockwise direction of the vectorial angle should be taken as the positive direction, and in this picture over here, in this new picture, the anti-clockwise direction of the vectorial angle should be taken up as the positive direction because of the position of this initial axis. Got it? So the position of the initial axis determines the direction of the vectorial angle. And now, if we consider this kind of any arbitrary point having vectorial angle theta and radius vector r, small r and theta, these are the polar coordinates of any arbitrary point P on this curve. Okay, and we know that the eccentricity E, the definition of this eccentricity, this is actually the ratio of two distances. What kind of distance? Distance of any arbitrary point P, distance of this point from this kind of fixed straight line, that is the directrix. That means over here this much distance from starting from P to M, this much distance should be is equal to the distance of the point P from this fixed straight line, that is directrix. Therefore over here, this eccentricity E is equal to PS by PM. This is the ratio of the eccentricity, and therefore, from this relation, we can say that this distance PS, or you can say, if you want to find out this distance PM, this distance PM should be is equal to PS divided by E. Got it? Therefore, this Pm should be is equal to R divided by E. PS means the distance R divided by E. Alright. That's why over here this in this relation, if you look at this expression, this over here, this is this kind of relation you would find that PS is equal to E into PL. You see, PS would be is equal to E multiplied by this PM. Got it? And therefore, we finally you can say that yes, this much distance R. You see over here, this much distance R should be is equal to this much distance R should be is equal to PS, that is actually E into PM. You see this R is equal to this distance PS or SP, that is equal to E into PM. And what is PM? Over here you see this starting from P to N, M, this much distance, this PM, this much distance would be is equal to this much distance. Okay, and therefore we can say that this PM must be is equal to nx. Therefore, in place of PM, we can write nx. Now, what is nx? This nx is actually this much distance sx plus this much distance sn. So we write it sx plus sn over here. Okay. Now, as per the definition of this eccentricity E, let me write it over here. E should be is equal to PS divided by PM. This is the definition of eccentricity, the ratio of these two distances. E is equal to PS by PM. Now, suppose if this point P coincides with this point, that is actually the one end of the lattice rectum L. Okay, if this point P coincides with this point, in that case, in place of P, we can write L. In place of P, we can write L. Okay, and therefore we can say that this eccentricity would be is equal to Ls divided by Lm. This eccentricity would be is equal to Ls divided by Lm. Okay. Now, what is LS? This LS, this is actually the semi-lattice rectum L. What is L? Generally, we define L is equal to B square by A. That is actually the semi-lattice rectum. this much distance, the straight line through this point A is this much distance. This is actually the total lattice rectum. This much distance is equal to the lattice rectum. Clear? So the lattice rectum is actually this kind of distance. This kind of distance is the total length of lattice rectum, and half of this is actually the semi lattice rectum. Okay. Now you see over here, what we can write? We can write this LS. This LS is actually this LS. This much distance is equal to the lattice rectum L divided by LM. Hmm. Uh, Now, what is L? Not M. Rather, in place of M, we have to write M1. Clear? So it should be M1. L M1. L M1. Got it? L divided by L M1, small l divided by small l M1. So L to M1, this much distance, L to M1. Now this L to M1, this much distance is actually is equal to the distance Sx over here. This much distance is equal to the distance Sx. Therefore, we can say in place of this LM1, in place of this LM1, we can write Sx. Clear? We can write this much distance Sx. And then what is L? This L should be is equal to E multiplied by this much distance Sx. Clear? And therefore E into Sx, over here you see we have an expression of E into Sx. So this E into Sx, that must be is equal to L. Okay. This E into Sx, this expression, this E into Sx, that must be is equal to this expression of L. This is the first term. And what about this second term? This second term is equal to E multiplied by Sn. So E multiplied by Sn. And what is Sn? You see over here, this, if you consider this triangle PSN, if you consider this triangle, then with respect to this angle, this distance is actually the base. R is the hypotenuse. Therefore, cos of this angle, say cos of this angle PSN, cos of this angle, PSN, this distance, this should be is equal to base Sn divided by hypotenuse R. Base is actually our Sn divided by the hypotenuse R. Therefore, this Sn, this numerator Sn must be equal to R multiplied by cos of this angle. Got it? That's why E stays over here, just similar to this expression. E does not change. Just in place of Sn, we have over here they have written R into cos of the angle PSN. Got it? So E is not changed. This eccentricity E is not changed. Just in place of Sn, they have written R cos of the angle PSN. Clear? Now, what is the angle? This angle PSN. Now, in place of this first picture, the angle PSN, you see what is PSN over here? The theta is this angle XSP. This is the angle theta. Therefore, this angle should be is equal to pi minus theta. So, with respect to this picture in the book, they have considered the angle. Therefore, we can say that this angle is equal to pi minus theta. And what is cos of pi minus theta? Cos of pi minus theta is the negative of cos theta. That's why we got this negative symbol over here. Negative of cos theta. Now, if this last term is taken on the left hand side, what we have on the left? On the left we have r, this small r. Then what we shall have, if this expression, this term is taken on the left hand side, we shall have that L is equal to this term. L is equal to the on the left we already have this small r, and this negative symbol would become a positive symbol. So plus E into r cos of theta. So we can take one r common and divide the entire expression by small r. So if we divide the entire expression by small r, then what we shall have? We shall have L by r is equal to 1 plus E cos of theta. L by r is equal to 1 plus E cos of theta, and that is actually a relation in between the coordinates r and theta. The relation in between the coordinates of an arbitrary point r and theta lying on this curve. Got it? And therefore this would be the equation. This would be the equation of the or the polar equation of the conic. Clear? L by r is equal to 1 plus E cos theta would be the polar equation of the conic. This conic. But what is the difference in between this conic and this conic? Actually, the curve is same. Just the initial axis, the position of initial axis is changed in between these two pictures. So we expect that if we consider this kind of picture as well, if you consider this picture, then you see with this angle in this first picture, this angle was equal to pi minus theta, but in this second picture this angle is equal to theta. So if we consider the second picture, you see in place of pi minus theta we shall simply have only theta. Got it? So plus E into r cos theta. Over here in this position a plus symbol would come. In place of negative symbol a positive symbol would come. Positive sign would come. Got it? And whenever this term is taken on the left hand side, you see in place of this positive symbol we shall have a negative symbol. Got it? And whenever it is divided by r, again we shall have a negative symbol. So 1 minus E cos theta would come. If you consider this picture, in that case 1 minus E cos theta would come. If you consider this first picture, in that case L by r is equal to 1 plus E cos theta would come. If you consider this second picture, in that case 1 minus E cos theta would come. Got it? So in this way we define this, we compute the equation of a conic with respect to two different kind of initial axis. And how to remember this result? What I advise is that if you consider this first picture, you see with respect to this focus S, with respect to this focus S, this initial axis and the position of directrix both are in same direction. Okay, and that's why we have positive symbol over here. So if we find that initial axis and the directrix are in the same position, then we shall have a positive symbol over here. However, if you consider this picture, what we observe? We observe that with respect to this focus, the initial axis is situated in right side. In the positive direction of initial axis is right side, and this directrix is situated on the left side. So they are in opposite direction. So if the opposite direction, if we get some opposite direction like this, then we will get the equation of the conic as equal to L by R is equal to 1 minus E cos theta. So in that case negative sign would come in place of positive symbol. So if we have similar side of initial axis and the directrix, then positive symbol would come. If we have opposite sign, opposite sides of initial axis and this directrix, in that case this negative sign would come. So in this way we generally try to remember the equation of both of these two cases. And what I have this picture, what I have told about this picture, everything has been written in just as a note only. You see, this is the note number 1 over here. They have just seen, without any deduction, they have just said that the equation would be is equal to 1 minus p cos theta. So that is all about this second picture. Got it? And sometimes it may so happen, let me show you this kind of picture over here. Sometimes it may so happen that you get this kind of picture. What is the difference in between the previous picture and this picture? The difference is that over here, just this angle, this straight line, you see, this is the straight line. Let me show you from using this one. This is the straight line. This is the axis of the parabola. Now initially the axis of the parabola and the initial axis both are same. But now over here, in place of this axis of the parabola, we suppose that the axis is inclined at an angle alpha. The axis is inclined at an angle alpha with the axis of the with the initial axis of the polar coordinates. Got it? So the axis of the this axis of the parabola is now inclined at an angle alpha with the initial axis of the polar coordinate system. I don't know in the book whether they have taken the angle alpha or gamma. Maybe it is gamma. Maybe in the book. Let me check. No, they have taken this as alpha. Okay, fine. So we can continue with this picture. Got it? Now you see in this picture, in this picture, this angle is alpha and this is the vectorial angle. This theta is the vectorial angle. So initially this much angle was equal to theta. And now the total, this much total entire angle is equal to theta. Clear? And when entire angle is equal to theta, we were actually interested in this angle PSN. We were interested in this angle PSN. This is the angle PSN. Got it? And in such case, whenever we have this angle, you see this angle is actually this PSN. This angle is actually is equal to theta minus alpha. This angle is equal to actually theta minus alpha. Got it? And that's why in this equation, in place of simply theta, we have this total expression of theta minus alpha. So this is you would hardly get one or two problems of this kind, because in most of the problems this axis of the parabola and the initial axis both are same, but only in one or two selective problems you will get this kind of general case. Got it? You will get this kind of general case, and in this kind of general case only you will find that the axis of the parabola is different from the axis of the initial line, and in that case this angle would be is equal to theta minus alpha. This total angle is equal to theta, and this angle, the angle PSN, the angle PSN is equal to theta minus alpha, and that's why we shall have theta minus alpha in place of simply theta. Got it? Whether it is plus or minus, it doesn't matter. In both of these two cases, in place of theta, we encounter theta minus alpha. Okay, so this is the equation of the conic in terms of polar coordinates. Got it? Now we don't need the detailed discussion on this kind of nature of the conic. We all know how the nature of the conic is. In case of parabola and in case of hyperbola, we have two infinite branches, and in case of ellipse, the nature of the conic is actually a closed nature. So we don't need this result. Rather, what we need from this result is the length of the semi-axis of an ellipse, and the length of the semi-axis of an hyperbola. Over here, uh, this would be, if this is the ellipse, and suppose these are the major axis, and and this is suppose the minor axis. Hmm? This is the minor axis. Hmm? So yes, and the lengths of the semi-axis. Semi-axis means this is actually the same total major axis. So half of this major axis is called the semi-major axis, and half of this minor axis, that is called the semi-minor axis. So semi-axis means semi-major axis as well as semi-minor axis. And how to get the length of this semi-major axis? These are the two formula: L divided by 1 minus e square and L divided by root over of 1 minus e square. The largest is the semi-axis and the smallest value is the semi-minor axis. Got it? Remember, this is actually L, not 1. You generally make this kind of mistake in exam. Generally, you write 1 divided by root over of 1 minus e square or 1 divided by 1 minus e square. So this is actually this in the numerator. This expression is actually L, not 1. L means the semi-latus rectum. What is semi-latus rectum? We know that if you consider a straight line through the focus, say this is the focus. In that case, this if this is the focus S, then this much length is actually the semi-latus rectum. This much length is called the length of the latus rectum. Got it? So this L is all about that semi-latus rectum. L divided by 1 minus e square and L divided by root over of 1 minus e square. Clear? So these are the two formula that you need to remember about ellipse. This is all about ellipse, because in case of ellipse we know that E is always less than 1, hmm, and that's why 1 minus e square is a positive quantity. But in case of hyperbola, this E is greater than 1. That's why in case of hyperbola, it can be proved that in place of L by root over of 1 minus e square over here, if you look at this expression carefully, this over in this denominator, root over of e square minus 1 is there, because of the fact that E is greater than 1. Here, so be very careful. Similar kind of formula is there in case of hyperbola as well. We can define two semi-axis, and the length of the semi-axis are L divided by 1 by e square minus 1 and L divided by root over of e square minus 1. Just try to remember the fact that in case of hyperbola, E is greater than 1, and in case of parabola, E is less than, in case of ellipse, E is less than 1, and accordingly this square root expression has to be modified. In case of ellipse, we had root over of 1 minus e square because E was less than 1, but in case of hyperbola, E is greater than 1, therefore root over of e square minus 1 would ultimately come. All right. Now we consider the equation of directrices. Directrix, you see, generally in case of ellipse and in case of hyperbola, we have two different directrices. One is the directrix near to this first focus, and another is the directrix near to this second focus. This second focus, if we call it S prime, in that case, this is the directrix near to this second focus, and this is the directrix near to the first focus. Now over here the question is that what is the pole, which focus has been chosen as the pole. Over here in this picture, this focus S, this point has been chosen as the pole. So with respect to this pole, we can consider one directrix as near the pole and another directrix as far away from the pole, because pole is always fixed. If this focus is chosen as pole, then this is the directrix near to the pole and this is the directrix far away from the pole. Here, so we need to compute the equation of both of these two directrices. we need to compute the equation of this directrix PZ. Similarly, we need to compute the equation of this directrix P prime Z prime. Hmm. And this is S. Clear? S over here, this S has been taken as the pole, and as per this discussion in the book, the initial axis is taken in this direction. Clear? Because you see over here, this angle is measured from this position to this clockwise direction. So it is clear that the direction of this initial axis is taken on the left hand side with respect to S. So we can consider this kind of angles as the vectorial angles. We can consider this kind of angle or this kind of angles as the vectorial angles over here. Now let us try to find out the equation of the directrix whenever S is this focus and the initial axis is the direction of the initial axis is taken as the left side direction. And as because with respect to this S, this directrix and this nearmost directrix and this direction both are in same direction, that's why they have taken plus symbol over here. L by R is equal to 1 plus E cos of theta. And for the time being, we have taken E less than 1 as an ellipse, because we are considering firstly the ellipse. And similar kind of result again comes in case of hyperbola. So you don't need to separately study all these. In both of these two cases, the ultimate equation of the directrices would be same. So you don't have to bother about it. Whether E is less than 1 or greater than 1, it doesn't matter. Now you see in this picture, uh, what we do whenever we are interested to find out any equation of any curve, that maybe that curve is actually a straight line, maybe that curve is actually a parabola, it may be an ellipse or hyperbola, it doesn't matter. So over here we are interested to find out the equation of this straight line, PZ straight line. That's why on this straight line we take any arbitrary point P. Got it? We take any arbitrary point P, and suppose this r and theta, these are the coordinates of this point P. Okay, r and theta, these are the coordinates of the point P, r comma theta. All right. And if this is r, this coordinate is equal to r comma theta, then what is r? You see, P to S, this much would be the this much would be equal to the distance r, that is the radius vector. Okay, PS should be is equal to r. And what would be theta? Theta would be is equal, it would be measured from this direction. So this angle should be is equal to the angle theta. This angle should be is equal to theta. That means PSZ. So PSZ. This angle PSZ, this angle PSZ would be is equal to the angle theta. Clear? And in that case, let me again divide this picture. Let me show it in this fashion. We need to divide the screen in this fashion, otherwise it is not possible to show all this computation. Yes. Now you see, what is SZ? What is the distance SZ? Now let me show you a picture for you in order to understand what would be the distance SZ. What would be the distance SZ? Let me firstly consider this kind of picture. Let me show you this kind of picture. Just a minute. Let me show you this kind of picture. Okay. Now you see, if you consider an ellipse, maybe this is the ellipse. Maybe this is the ellipse. You see, this may be the major axis. This may be the directrix, and say this is the focus S. Now, in case of Cartesian coordinates, what we did in case of Cartesian coordinates, we generally studied the minor axis, and generally this point was taken as equal to the origin O. And we had two different foci, one is S, another is equal to S prime, and we know that their coordinates are AE comma 0 and minus AE comma 0. Better to say plus minus AE comma 0. These were the coordinates of these two foci. This is one focus and another is this much focus. So what is S? This much distance, this much distance would be is equal to our AE. Got it? This much distance would be is equal to AE. And we had one more result, that the equation of these two directrices, these equations are x is equal to plus minus plus minus how much, A divided by E. Okay, that was the these were the equations of the directrices. These directrix stands for plus, and then this directrix stands for minus. So what I am trying to say is that this much distance would be is equal to A divided by E. Got it? This much distance would be is equal to AE, maybe plus, maybe minus. In the positive portion we have plus AE, in the negative portion we should have minus AE. That's why the coordinate of this point would be is equal to minus AE comma 0. Got it? Anyway, this much length would be is equal to AE. Okay, and this much length would be is equal to again A divided by E. So keeping this result in our mind, what would be the length of this portion starting from S to this was the point Z. SZ, we were interested in this length SZ. Okay, so this much length would be is equal to, you see, the total distance is equal to A by E minus AE. So A divided by E minus AE. This much would be the length, this much length, that is length AZ. So AZ, this AZ should be is equal to, that should be is equal to AE divided by A minus E. So if you want, you can compute SZ in this fashion as well. It doesn't matter. But if you further want to tally this result with the result of with the result of your book, in that case you can take this E as the LCM, and if you want to consider this numerator expression A minus A E square, this kind of expression would come. And A minus A E square, if you take this A common, then we will have 1 minus E square, 1 minus E square divided by E. That would be the expression of SZ. And if you further compute this result, ultimately you will get this result that has been written in your book. This SZ would be is equal to L by E. Let me hide this result. This SZ, this distance SZ would be is equal to L by E. Ultimately by computation you will be able to compute the result. Sz is equal to L by E. And from this for this directrix PZ, this directrix PZ, this angle is actually our angle theta. This much length PS is equal to the length R. Got it? So if you consider this triangle PSZ, if you consider the triangle PSZ, P then S and then Z. If you consider this triangle PSZ, then cos of theta should be is equal to this much length SZ divided by the hypotenuse R. Again, I am saying that cos of theta would be is equal to SZ, okay, divided by this R. That should be is equal to cos of theta. That should be is equal to cos of theta. So what would be SZ? SZ would be is equal to R cos theta. You see, R cos theta would be is equal to SZ, and SZ is equal to, over here you can prove that is equal to L by E. This much is equal to L by E. And therefore from this result we can prove that L by R is equal to E cos theta. So if L by E is equal to R cos theta, L by E is equal to R cos theta, then we can prove that just divide this expression by R and multiply this expression by E. In that case, we will get this result. L by R is equal to E cos of theta. L by R is equal to E cos of theta. So L by R is equal to E cos theta. This is actually a relation in between R and theta. And that is obtained by considering an arbitrary point on this straight line, that is actually the directrix. Got it? Therefore, the equation of the directrix is L by R, this nearby directrix, equation of this nearby directrix would be L by R is equal to E cos of theta. And now if you consider this second directrix, what would be the equation of this second directrix? Then in order to compute the equation of this second directrix, we need to similarly consider a point P prime over here, just similar to a point P in the previous directrix. Again we need to consider a point P prime over here. Got it? And now as because we are interested in this second directrix, in the equation of this second directrix, therefore this coordinate of the point P, that has to be taken as R and theta. Got it? This arbitrary point, coordinate of this arbitrary point has to be taken as R and theta. Then what would be the distance R? You see, this much distance would be is equal to the radius vector R. Starting from the focus, everything has to be measured from focus. The radius vector is always measured from focus. Therefore, this much length from S to P prime, that has to be is equal to R. And what is theta? Theta should be measured in this direction. You see over here, this was the initial direction, not this direction. Clear? Not this direction. So S to Z, this is the direction of this was the direction of initial axis. That's why we took the equation as 1 plus E cos theta. Otherwise, we had to take 1 minus E cos theta. So that's the different issue. Therefore, this angle would be is equal to theta. Got it? And again, we need to compute this much distance. Then how to compute this much distance? Let me show you the picture again over here that we considered in this discussion. Over here you see this much distance, this was the position of P prime, this was the position of P prime. And we considered this kind of straight line, a straight line from the focus S, that was actually taken as the pole. And what we are interested in, we are actually interested in this kind of distance. We are interested in this kind of distance. S to Z prime. We are interested in S Z prime. Then how to compute S Z prime? You see, S Z prime. How to compute this S Z prime? We can compute this S Z prime by firstly computing this much. Let me clear this picture a bit, because this is a very clumsy picture. Um, hmm. Now, how to compute this much length from S to Z prime? We can compute this much length. And what is that length? That length is equal to A by E. This much distance from O to Z prime. That distance is equal to A by E. Got it? So A by E, and this much distance is equal to AE. Hmm. So the total SZ prime over here should be A by E plus AE. So plus symbol would come. Plus symbol would come. Hmm. And you see, by this kind of computation, we would ultimately get this result. It is over here. Hmm. You see, we will ultimately get this final expression. That would be the expression, this much distance is Z prime. So this total is Z prime would be is equal to L by E into 1 plus E square divided by 1 minus E square. Hmm. And again, if we consider this triangle, in that case, with respect to this angle is equal to actually pi minus theta. This angle would be is equal to pi minus theta. So if we want to find out the cos of that angle, so that this cos of pi minus theta, this pi minus theta, cos of pi minus theta, this length, this angle cos of pi minus theta, that would be is equal to this base sz, s of, not sz prime, sorry, sz prime divided by the hypotenuse. Hypotenuse is equal to from s to p prime, this much length. This is actually our radius vector r. So sz prime divided by r. Got it? So in this fashion, if you consider the computation process, you see you will get this type of result. A z prime is equal to r cos of pi minus theta. S z prime would be is equal to r cos of pi minus theta, and S z prime is equal to L by E into 1 plus E square divided by 1 minus E square, and cos of pi minus theta, that can be considered as minus cos of theta. And then after manipulation, just this negative sign would come over here. This negative sign would come over here, and in this negative sign, in this negative symbol, L by R minus 1 minus E square divided by 1 plus E square into E cos of theta, this kind of symbol would ultimately come. Got it? So ultimately we will have this kind of result, that L by R is equal to minus of 1 minus E square divided by 1 plus E square into E cos of theta. So that is actually the equation of this second directrix. L by R is equal to minus 1 minus E square divided by 1 plus E square into E cos of theta. Got it? So these are the two equations of the directrices. One is the L by R is equal to E into 1 minus E into cos of theta, and second one is L by R is equal to minus of 1 minus E square divided by 1 plus E square into E cos of theta. So these are the equations of the directrices in case of an ellipse. And in case of parabola, when E is greater than 1, then also the same equation again takes place. Just if you shuffle them as minus of 1 minus E square, you can write it as E square minus 1 in the numerator. Minus of 1 minus E square can be written as E square minus 1 in the numerator, and therefore this expression can also be written as equal to, you see on the numerator we have E square minus 1 divided by E square plus 1 into E cos theta, and the first directrix remains same. L by R is equal to E cos of theta. So these are the two equations of the directrices in case of hyper, and in case of parabola only one equation comes over here. L by R is equal to simply cos of theta. L by R is equal to cos of theta is the only equation of the directrix. That's all. So that's all about the directrix equation of the directrix. And thank you for being with me in this class.